Now we're going to look at performing operations with vectors in terms of I and j. So the way we can do this is that we represent I is the vector 1, 0, so it's a unit vector. In the horizontal direction, j is the vector 0, 1. So we're able to rewrite something in terms of I and j. So given a vector v with the initial point p at x1, y1 and q at x2, y2, v is written as v equals x2 minus x1 times I plus y2 minus y1 minus, that should be y2 minus y1 times j. Okay. So the position vectors from 0, 0 to AB, where x2 minus x1 is A and y2 minus y1 is B, is written as v equals AI plus bj. This vector sum is called a linear combination of the vectors I and j. So the magnitude of v, which is AI plus bj, is v, magnitude of v is the square root of a squared plus b squared. And here's a visual representation. So you have the vertical component, the horizontal component, and that's your vector there. So for example 10, it says given a vector with vector v with initial point p at 2, negative 6, and terminal point q at negative 6, 6, write the vector in terms of I and j. Okay, so we're going to have, let me get a little space there. Our vector v is going to be equal to negative 6 minus 2. No, I'm doing this in the ij component. So negative 6 minus 2 times I plus 6 minus negative 6 times j. So that's going to be negative 8I plus 12j. Okay. And the next one, we have given the initial point P at P1 is negative 1, 3, and the terminal point P2 is 2, 7. Write the vector v in terms of I and j. So v is going to be equal to, again, same thing, 2 minus negative 1 times I plus 7 minus 3 times j. So it's going to be 3I plus 4j.